Alright, so today we're going to be looking at how to solve and graph inequalities. Words such as at most, at least, more than, less than suggest a relationship where two quantities are not actually equal. So we call these inequalities. So we have four different inequalities. We have greater than, which is used whenever a quantity is bigger than another quantity. Less than, whenever a quantity is less than another quantity. We have greater than or equal to. Now in this case, this quantity could be equal to the other value, or we have less than or equal to, and it could also be less than or equal to another quantity. So being able to move between words and symbols in words is very important. So we want to write an inequality for the sentence 5 fewer than a number is at least 12. So fewer than here, I want 5 fewer than a number. Well, how do I represent some number that I don't know what it is? Well, that's a variable, so I'm going to call that x. You could call it any variable you want. So 5 fewer than this number, so I want 5 less than this number. Now here, that is not an inequality symbol, that is the subtraction sign. So less than this number 5 is at least 12. So what does this word at least mean? At least means it could be bigger, but at the very minimum, it could be 12. So at least 12, it could be bigger, but it's at least 12. And I have to use that equal to sign there because at least 12 means it could be equal to 12. That's the smallest value that this quantity could be. So whenever we want to graph these types of inequalities, we have four options here. Whenever we're talking about greater than and my variable is on the left-hand side, greater than means that I cannot actually achieve the value on the right-hand side. So if you look at the graph, I have an open circle on that value 4, and greater than I'm shading towards the directions of numbers that are bigger than 4, so towards the right. Whenever I have greater than or equal to, well, now I can actually be the value of 4. So instead of an open circle, we have a closed circle to represent I can be the number 4. And again, because my variable is on the left, I'm going to shade towards the values bigger than 4, so to the right. Less than, same idea here. Because there's no equal to sign, it's an open circle, and I shade to the values that are less than 4. Less than or equal to, I'm going to have a closed dot now, and I'm going to shade again to the values that are less than 4. So please remember that the only time you actually follow the sign here, so this sign is pointing to the right, I shade to the right, is when the variable is on the left-hand side. So the variable on the left, you're going to just shade in that direction. Now we can always move it so the variable's on the left. So please understand that if I say x is greater than 4, that is the same thing as 4 is actually less than x. So those two things are exactly the same. So one of the biggest mistakes that students make is they forget whenever they multiply or divide an inequality by a negative value, that inequality symbol will flip over. So less than will become greater than will become less than, and so forth. So let's say I have a value, a is bigger than b, and let's actually give that a concrete value. So let's say I'm talking about 8 is bigger than 5. So I'm letting a be 8 and b be 5. And this is just one specific example just to show you why it works. Now, if I were to add something to 8 and then add that same value to 5, this inequality would still hold true. Like if I added 1 to each side, 9 would be still bigger than 6. So that stays true. If I were to subtract 2 from each side, so let's say now I become 6 is bigger than 3, that's still a true statement if I were to subtract values on each side. Well, let's say I am going to multiply each side by a positive value. So I'm going to multiply each side by 2. So if I multiply each side by 2, 16 is still bigger than 10, so that still works out. If I were to divide each side by a certain value, let's say I divide it by 2, well, that means I'm going to have 4 is bigger than 5 halves. 5 halves we know is 2.5. That's still going to be a true statement. So now let's look at a special case where I'm going to take away 8 from both sides and then take away 5 from both sides. So if I start with 8 is bigger than 5, and then I take away 8 from each side, I get 0 is bigger than negative 3, which is still a true statement. Now, if I take away 5 from both sides, I get -5 is bigger than -8, which is still a true statement, but I want you to look at what just happened. I said that A was 8 and B was 5, so let's kind of substitute that back in. A was 8 and B was 5. And look what I have now. I went from A bigger than B, 8 bigger than 5, and then I moved things around. I used my algebra skills, and I did nothing that violated any math rules, and I ended up with -B is bigger than -A. Now remember, we talked about this. We can actually rewrite this as -A is less than -B. So comparing this to the initial statement here, I multiplied or divided each side by -1, and the inequality sign happened to flip. Alright, so now let's actually solve an inequality. So this is very similar to just solving a regular equation, except for I'm going to have to take into account anytime I multiply or divide by a negative number, just in case my sign flips. So, first things first, I have to distribute. So distributing this -2, so -2x minus 18 plus 5 is going to be greater than or equal to 3. Now I'm going to combine like terms on the left-hand side. So I'm going to get -2x minus 13 is greater than or equal to 3. Now I'm going to bring my -13 over so that it can be with its common term 3. So I'm going to add 13 to each side. You do the inverse operation there. So -2x is greater than or equal to 16. Now to undo the multiplication here, I'm going to divide by -2. Now, since I am dividing by a negative number, what I do is always circle that inequality symbol so it signals me that I have to flip it. So now, writing my final answer, I'm going to get x is less than or equal to -8. Now to graph that, my key value is going to be -8. And I like to always make sure that I have 0 on my number line as well. So I'm going to have a closed circle at my key point here, -8, because I have that equal to sign. And then I am going to shade to the left because my variable is on the left. I know I just shade in that direction. Now you could check your values. What values are less than or equal to -8? Well, -9, -10, -11, and those values are in my shaded region. So will this inequality be always, sometimes, or never true? Well, in order to tell, we need to isolate the variable x. So I'm going to continue to distribute. And then I'm going to try to isolate my x value. So I'm going to add 2 to each side. And then I'm going to add 6x to each side. And whenever I do that, and I actually add these together, I'm going to get 0 is bigger than 9. Well, when is 0 bigger than 9? Well, I hope that 0 is never bigger than 9. That is not a true statement. So I would say this is never true. Whenever you get a statement that is always true, such as 8 is bigger than 5, we would say always true for that one. And sometimes is going to be whenever you actually can isolate the variable without it going away in your inequality, such as x less than or equal to 7. That would be a sometimes statement. Alright, so here are a few problems I would like you to try.